Hey, this is Ryan Jones from Serverless Guru. In the last video, we covered app, which was our whiteboard for our application. And what we basically did is we showed how to go through this full flow. So if you haven't watched that yet, go back and watch that, because that'll show you how we move through this entire diagram here. The first piece that we're going to cover is actually the Lambda function. So we're going to cover how to basically do and how to build a Lambda function. This is probably the most important piece out of these three, I would say, because it is your compute, it's where your business logic goes, it's the brain of your application. So what we're going to do is switch back to the AWS console. We're going to go to Lambda. I'm actually going to switch to a different region just for the sake of it. So I'm going to use, I was in Oregon because that's where I'm based out of, but I might actually go to, let's go to Ohio. Once we're in Ohio, we're going to start building some stuff. So let's go to Lambda. So let's go ahead and look at so AWS Lambda, dashboard, applications, functions, layers. So what we're going to do is we're going to just jump into the most basic Lambda function possible. So we're going to hit create function. And then we have a couple of options here. We can do author from scratch, use a blueprint, or browse a serverless app repository. So these are all really good. This is something I would recommend diving deeper into. I can kind of give you a background of what this means. So a blueprint would be, imagine you wanted to get something from S3 and you're using Python 3.7. You could select this blueprint and it would give you basic code to do that. If you wanted to go a little bit more advanced and you wanted to see other stuff that's out there, you could say, okay, this is an image resizer service. And so you would basically click on this, it would give you the code, and it would show you how, it would basically give you the code to resize images for S3. There's a lot of cool stuff that we can do here. For our purposes, we're going to build it from scratch, but definitely take some time. If you ever have an idea, like you see a lot of stuff here, like Alexa skills, Alexa smart home, what I would say is take the time to actually go through here and figure out how to work it into your applications, because the core thing here is don't reinvent the wheel if you don't have to, and use a blueprint or use this application repository to help further speed up your development. So for now, let's say author from scratch. We're going to call this one create user. We're going to use Node.js 10. For execution role, this is kind of like giving it permissions to do things. We're just going to stick with the normal. And we're going to hit create function. So now this is going to create a Lambda function, aka a cloud function, with a Node.js runtime. And yeah, once it's fully created, we can actually set up a test. So the first thing that we're going to do is hit select test event. We're going to say configure test event. And this is just a very basic test. So we'll say XYZ. And what it's going to do is it's going to send this object to our Lambda function, and then our Lambda function is going to respond back. So let's hit create. I'll close out this success message at the top, then hit test. So there we go. So we get this execution result succeeded. And if we hit the details, we can see that there was a status code that came back and a hello from Lambda. So that means that it's working. And then down here we have some CloudWatch logs. We're going to cover this in more detail in one of the other videos coming up. Down here we have this designer section. The designer section basically gives you a visual way of understanding what your application is doing. So for instance, our create user Lambda has access to talk to Amazon CloudWatch. So that's how Amazon CloudWatch can monitor our Lambda function, because it has that permission. And so let's go ahead and scroll down a little bit more. So here's our function code. So you can actually see that this is our whole backend, right? So our whole backend is just this, 8 lines of code. So we can go in here and change this and say, welcome to the Serverless Guru course. And let's hit save. And then if we scroll back up to the top, I'll close out this message. We can hit test one more time. And there we go. You can see the message changed. So what we just did is we just changed our backend code by just doing this inline, text edit here. And you can get more advanced with this, right? So you can do a ton of stuff. So if we wanted to throw a 500 error, like let's say we wanted to say if the event dot p1 is equal to error, then we want to say this. And instead of const, we'll use let. And then we'll say else if event.key1 is equal to s. Then we want to set the response to have a status code of 200. And then we'll say, oh no, something's wrong. And then this one will say, everything is groovy. Then finally at the very bottom, we can say response. So at the top, we gotta add a variable called response. So we'll say let response equal, let's do that. So now what's gonna happen is our function's gonna run. It's gonna check the event object. That's what that test was. So if you remember this thing. And then here, we're gonna set this to error. We can kill the other ones. And we can hit save. So if it's error, it's going to send back a 500 that says, oh no, something is wrong. If it's success, then it's going to say 200, and it's going to say everything is groovy. So we can save this, and then we can test it. So we should get it back an error message. So it looks like there's no logs happening, so let's go ahead and dive into this. Do console.log response. Just saying that response is undefined. Let's try to set it to an empty object and then test it again. Okay, so it looks like it's not actually getting inside of our else if here. Let's take a look at the request body. We have key1, we have error. What we can do is we can print this out. So let's do, at the very top, we can do console.log, and we'll do event. And we'll test it. And we can see the logs down here, so we can see key1 is error. Event.key1. Okay. And then finally, say console.log response. Now that we know that those are working, I'll kind of delete these out. So we should be able to see something come back here, hopefully. Yeah, there we go. So we got response coming back there. But then as it moves forward, it's actually not setting it properly. So, and that's because we're reassigning it. Yeah. Fun stuff. Programming's fun. Cool. So if you got that very early and you're kind of, you know, pulling your hair out, sorry about that. So now if we scroll up, we can see that we have a 500 that says, oh no, something is wrong. And then we can change this to say success and save it. Test it again, and we can see everything is groovy. So now we're cooking with fire. And if we keep scrolling down, you know, you can kind of see an execution result here. Let me kind of, looks like we just went back. So we scroll past the function code, we can see environment variables. So for instance, if we throw something in here called like API key, then we say XYZ 1, 2, 3, 4, 5. So imagine this was like our Google Places API. And then if we save this, or actually let me scroll up, let me add some code in here. So we're gonna say
Places API.
Oh. my Google service kicked on. So under here, we're gonna say const API key and say process .env dot is API, and I think I had key on there too. Yep, key. So now what should happen is that API key should now be represented. So we should say, let's just do a console.log on the API key. And we'll add something here. We'll use some fancy syntax. So this is not a deep dive into JavaScript, but this is a way to do string concatenation in ES6 or 7. So you'll probably see me do this quite a bit. And if we then go to test it, see if we get any other logs. So we got API key XYZ12345. So that's how we basically communicate Lambda environment variables back to the Lambda function itself. So if we scroll down a little bit more, you can see that Google Places API XYZ, and you can see that in the logs that it actually printed it out. So for instance, if this backend that you're working on is going to search the Google Places API, grab a result, and then send it back to the front end. So basically like this flow, front end asks for a location, API gateway passes to Lambda, Lambda then searches the API gateway endpoint, or API gateway API. What other thing? The Google Places API. It'll come back to API gateway with your response, and then back to the front end and give that information to the user. So it's kind of a way to set that up. And then we can also do things like you can set up encryption. So this will help if you want to encrypt those, and then you can set tags. So we'll say created by. This is a good practice. It's basically every time that you create any resources on AWS, you add created by, because that way future developers can realize who it is. And then description, you can add a description of this. Create a user in DynamoDB. Memory, you can scale this up all the way to 3000 and back down to 128. For our purposes, we're going to keep it at 128. Our timeout's at 3 seconds. So that's a pretty short timeout. What we're going to do is let's bump this up to 10. So now what should happen is that we should be able to create a user, wait for the response to come back, and then respond back to the browser all within 10 seconds. It should happen, in like 2 seconds, but let's just create a kind of a big gap there. And then the execution role, this is for AWS IAM, so this is setting like what your Lambda function can do, right? So can it access DynamoDB? Can it do SQS? Can it do other things? The network, you can actually stick these Lambda functions inside of what's called a virtual private cloud, and that allows you to keep things like offline. Our purposes, we're not going to use it. One note there is that if you do create what's called a VPC Lambda, it will slow down quite a bit because when it starts up, it takes a little bit longer because it's inside of this virtual private cloud. And then debugging and error handling, you can set up what's called a dead letter queue. That's what DLQ stands for. A dead letter queue is basically, imagine if something fails, it just basically gets tossed into this dead letter queue. And you can come back, you can do like retries, or you can just basically come back and look at the failed invocations. So for instance, in this, if a user registers and this create user fails, we might want to have a delete or a dead letter queue so that we can actually come back later and do an audit on why all these requests were failing and what was inside the event object to make that fail. Like, why was this request failing when other ones succeeded? Concurrency limit here of 1,000. That basically means that you can have 1,000 of these Lambda functions running at once. So for instance, if we got 1,000 people registering for an account all at the exact same second, then we would hit concurrency limits. So we can have up to 1,000 users registering at the exact same time. Otherwise, we'll hit concurrency limits. And there's ways to get around this to get away from increasing it. But typically, you probably won't be running into concurrency issues very often at all, because if you're hitting 1,000 users registering per second, you're probably doing pretty well. So yeah, so let's go ahead and close out the video here. this was a high-level overview of what Lambda is. Of course, we're going to get deeper into this as we keep going. And yeah, I hope that you found this was useful, and I'll see you in the next video.